Hello, welcome to the video notes for lesson 7-2, quadratic functions. Alright, the learning targets for this lesson. I can graph quadratic functions of the form y equals ax squared plus bx plus c and determine its vertex or turning point. And I can use the formula x equals negative b, or opposite of b, over 2a to determine the axis of symmetry and the vertex. Okay, so considering the following equation, or quadratic functions, what is similar and what is different about these functions? Well, I think if you look closely, it's pretty easy to see what's the same and what is different. I'm actually going to focus on the top three first, if I'm going from left to right. When I look at these, and I look at the equations, you should be able to tell that we're dealing with the same parabola, in other words, the same curve, and the same concavity. They're all concave upwards. They're all concave upwards. So, what is different about all three of these? All three have different axis of symmetry and vertex. So, in class, we'll discuss how you can use your graphing calculator to find these turning points and to find the axis of symmetry for each of these. Oh, bad line there. Almost had it. There we go. That's the one. And then this one right here. Okay, so being able to find what those are, there's a few strategies. There's an equation we can use, and there's also the graphing calculator, which is a great tool. And we'll be using that tool a lot in this unit. Okay, going down to the bottom and looking at the other three graphs, going from left to right, I'm going to say almost the same thing. So we have the same parabola again. Same concavity. They're all opening upwards. Oops, that should be an O up there. And this, however, I'm not sure if you noticed, but all three of these have the same axis of symmetry. And that axis of symmetry is the line x equals 1 for all three of these. So the axis of symmetry is the line x equals 1. What's different? They all have a different vertex, or vertices. This point right here is different for all three. Okay? Alright, so that's all we're going to talk about on page 7. Over on page 8, we have a couple of examples. How to use the graphing calculator to graph a quadratic function and find its vertex. Now, some of you might say, oh, well, I can just type this equation into my graphing calculator, and boom, I have my graph. I'm good to go. I'll just copy it. It doesn't work like that. To do this the correct way, yes, you can use your graphing calculator to help you. It is not cheating. But what you need to do is to copy the table of values so that you can plot them on the graph. And that's how you show your work. And yes, you need to do this. So I know there are a bunch of people who think, oh, well, I don't really need to do that. I can fake it. You can try, but often it's not worth losing the points by faking it when you see how easy it is. So when you type this in and you hit graph, you'll see the parabola come up, and it's an arch shape. It's like this. Then if you hit second and then you hit the graph button, which shows you the table, you'll see a table. And the values that you're going to use, well, you're going to look at your grid that you have over here. Obviously, you want to make sure your turning point is part of the values. But I usually stick with the values that I can tell will fit on the grid. And when I do that, I see that my x values going from 0 up to positive 6 are the ones that I need. And it goes from negative 5 up to 4. Whoops. Did I skip something here? Looks like I did. Let me fix this. Let's try again. Usually 3 comes before 4. I knew it looked a little short. It goes up to 4, and then it goes back down to negative 5. There's our parabola. So then plot your points. So I have 0, negative 5. I have 1, 0. I have 2, 3, 3, 4. And then what's nice is, what I find is once I've found that turning point, finding my other points is pretty simple. Then draw your arch. Oh, I'm going to try that again. It does not have to be perfect, but don't make it that bad. And by the way, it's a little trickier on this slate than it is on your piece of paper. And yes, you need to label your graph. So y equals negative x squared. That's not a good squared. Squared plus 6x and minus 5. Alright, so find the axis of symmetry. That's the line that is right here. It's going right through the vertex. Probably makes more sense to find the turning point or the vertex first, because once you find the vertex, which is the point 3, 4, your axis of symmetry is the line x equals 3, which you can get right from here. Now, find the y-intercept and identify it on the graph. Here's our y-intercept. It is the point 0, 5. Oops, 0, negative 5, excuse me. Alright, pretty simple stuff. Let's go down to, actually, you know what? Why don't you try the one below on your own? Again, set up a table. You're going to find your x and y values. This one I'm going to have you do on your own. We'll see who completes it. Identify your axis of symmetry and your turning point after you plot your graph. Make sure everything looks good. Let's go ahead and take a look at page 9. We're running out of time here. Graph of a quadratic function. The graph of y equals ax squared plus bx plus c, where a is not 0, has the line x equals, so this is our axis of symmetry, x equals negative b, or opposite of b, over 2a as its axis of symmetry. The x-coordinate of the vertex is negative b over 2a. So we use this formula as a way of finding this without a calculator or without a graph. So find the axis of symmetry and the turning point. So we have y equals 2x squared minus 4x minus 6. Your a value here is the coefficient of x squared, that's 2. Your b value is the coefficient of x, that's negative 4. Yes, you need that sign. And then the c value is negative 6. We don't really need the c value for what we're doing so far, but it's a good habit to get into to write all these down. Okay, so now I use this equation, negative b over 2a. Well, b is negative 4. The opposite of that is positive 4. A is 2, so 2 times 2 is 4, so 4 over 4 are 1. So the axis of symmetry is x equals 1. Then you can plug that back into your equation for x and solve for y. So it's kind of like doing the check. And then you find your turning point or your vertex. So it's a nice algebraic way of finding your axis of symmetry and your vertex. So I'm going to do one example. I'll have you do this one on your own. Again, identify a, b, and c. The coefficient of x squared is 1. The coefficient of x is 5. And the constant is negative 6. We're not going to need that except for when we find our turning point. Okay, so x is equal to the opposite of b over 2a. Well, b is 5. I have negative 5 over 2 times, well, a is 1. So what is negative 5 over 2? You can do negative 5 over 2 or negative 2.5. Either way, doesn't matter. But there's our axis of symmetry. A of s is x equals, I'm going to do the negative 5 over 2. So there's one of our answers. Now to find the vertex, I plug this number in wherever I have an x. So y equals x squared plus 5x minus 6. So y equals, in parentheses, negative 5 over 2. By the way, if you don't use parentheses on your calculator, you might find your answer doesn't work out too well. Alright, when you substitute all that in and figure it out, you get y equals negative 12.25 or negative 12 and 1/4. So, our vertex is the point negative 5 over 2 or negative 2.5 and negative 12 and 1/4. Alright? Okay, the video is getting a little bit long, so I'm going to leave this one for you to figure out on your own. I will just tell you this. A is negative 1, B is 0, and C is 16. We only really need A and B for this. The answer works out to be pretty nice and actually pretty easy. So good luck. If you have any trouble, go back and rewatch the video or come see me for help, and we will see you in math.